to which...
Okay, question 6. The diagram shows genetically modified yeast growing in a fermenter in a medium to which the amino acid lysine has been added. Okay, a little diagram of a fermenter. Name the process for which the yeast cells need the amino acid lysine. Oh, that's a bit of a gift. You need it for protein synthesis. Okay, fermenter contains 5.5 litres of growth medium. Calculate the mass of lysine which should be added to the medium to give a concentration of 300 mg per litre. I genuinely looked at this and went, is it this simple a question? And it is this simple a question. Okay, you have 300 milligrams per litre, you have 5.5 litres, so you just need to multiply these together to give you 1,650. That's it, there's no conversions, there's nothing else. You can see why it's only 1 mark. Okay, the air entering the fermenter passes through a filter to prevent contamination. Explain why it is necessary to prevent contamination of the culture. Okay, so we need to stop contamination because we're basically trying to prevent competition. That's the best one I think you can go with. Okay, so this prevents competition with the yeast. Okay, so we don't have a problem with it losing its resources or anything else. Okay. The other thing is that obviously if there's competition with the yeast, then the yeast numbers might decrease, and you also might end up with things that you don't want to have in the solution. So you might end up with things that the contaminants are producing which are damaging to us if we're going to eat this or use this. Okay, optimum pH for yeast growth is 4.5. Suggest how this could be maintained. Okay, buffer is probably your best answer because that would just keep it at that area. But otherwise what you can do is you can just use probes and then just add acids or alkalis as required, obviously being very careful that it's something that doesn't do any damage to the yeast itself. Okay, B, we have phases of growth in a yeast culture, and we've got our standard phases here. So there's our lag, there's our log, there's our stationary. We don't have a death phase being shown. Okay. Complete the table by selecting growth phase A or B and name the chosen phase and describe an event which occurs during that phase of growth. Okay, so you were asked to either do A and say lag, being very careful that looks like an A and not an O. Okay, and then describe what's happening. Well, that one's just enzyme induction. It's the only thing you know as a thing about that. Okay, if you went for B, then you're going to say it's stationary. And if it's stationary, I think your best one to go for is secondary metabolites. Metabolites produced. But you also could reasonably say that we get toxic byproducts or toxic products build up, or waste build up. Okay. And in the mark scheme, they also allowed that we get depletion of resources. In fact, that was the first one they said. Okay. Describe a safety mechanism used to prevent the survival of genetically modified microorganisms in the external environment. Straight left from your content statements. What you have here is you need to have something, a gene which prevents survival outside your cultured conditions, outside the lab, basically. So that will be something which you've effectively engineered a flaw in the organism, which you need to give the thing that it needs to make that happen and be okay. That's the whole question.